Today we're breaking down code P0234 Turbo Overboost on the EA888. By the end of this video you'll know exactly what the code means, how the boost control system actually works, and the diagnostic process I use to find the real cause, not just the obvious guess. This is part 1 and part 2 combined, so let's get into it. Here's the first thing you need to unlearn: P0234 does not mean your turbo is bad. All this code is telling you is that the ECU detected actual boost exceeding requested boost, a control discrepancy. That's it. It's reporting a symptom, not naming a failed part. Keep that in mind, because it changes how you diagnose this. So why should you care if boost runs a little high? 2 big reasons. First, mechanical stress. Higher cylinder pressure loads up your pistons, rods, and head gasket, and the turbo itself can overspeed past its design limits. Second, thermal stress. EGTs climb, components run hotter, and eventually the ECU steps in with EPC or limp mode to protect the engine. This is why we don't ignore this code. Let's look at the system as a whole. This is a closed loop. Driver input turns into an ECU calculation, the ECU commands the wastegate actuator, the turbo responds, pressure sensors read the result, and that feedback goes right back to the ECU. Every cycle, it's comparing requested boost against actual boost from the map sensor. When actual boost exceeds target for long enough, P0234 gets set. Classic closed-loop control problem. The wastegate is the actual mechanism doing the work. When it's closed, more exhaust gas is forced through the turbine, spinning it harder, more boost. When it opens, exhaust bypasses the turbine, less boost. Every boost problem on this engine eventually traces back to whether this wastegate is doing its job correctly. Let's walk through the full 6-step loop. 1. The driver requests torque. 2. The ECU calculates the boost needed to deliver it. 3. The ECU commands the wastegate. 4. The turbo responds. 5. A sensor measures actual boost. 6. The ECU compares target versus actual, and the loop starts over. Any one of these 6 steps can be where things go wrong. Here's a concrete example. Say the ECU requests 1.8 bar, but the sensor reports actual boost at 2.5 bar. The ECU commands the wastegate open to bring it back down. If actual boost stays too high anyway, P0234 gets stored. Just remember, these numbers are illustrative. Exact thresholds vary by software calibration. Quick comparison so you don't mix these up. P0234 is overboost, actual boost is greater than requested, too much pressure. P0299 is the opposite, underboost, actual boost is less than requested, not enough pressure. Same control loop, opposite failure direction. 6 sensors feed this whole system. Map or charge air pressure is your primary feedback. Intake air temperature handles density correction. MAF, where fitted, gives mass flow. Throttle position gives load context, the accelerator pedal shows driver demand, and engine speed provides the RPM reference. If you're chasing a boost code, these are the data points you need to be watching. Before you touch anything mechanical, verify the map sensor. Key on, engine off, it should read near atmospheric, about 1.0 bar or 14.5 psi. At idle, it should shift appropriately with the vacuum or boost region. Under acceleration, pressure should rise smoothly, no spikes or dropouts. And don't skip the physical check, inspect wiring and connectors for corrosion or damage before you condemn any part based on a bad reading. The actuator itself has 4 parts working together: the electric motor that drives the linkage to open and close the flapper, position feedback that tells the ECU where the actuator actually is, internal electronics handling control and diagnostics, and the mechanical linkage connecting the actuator arm to the wastegate flapper. A fault in any one of these 4 can trigger a boost code. Here's what actually goes wrong in the field: sticking linkage, carbon or corrosion buildup, general mechanical wear, a damaged linkage, actuator motor failure, or a position sensor and wiring fault. Notice, none of these are the turbo itself. This is exactly why jumping straight to a turbo replacement is usually the wrong move. This step trips up a lot of people. The mechanical position of the wastegate has to match what the actuator feedback tells the ECU. Misalignment creates false over or under boost conditions, even with a perfectly healthy turbo and sensor. So after any actuator work, you must perform adaptation, or basic setting, so the ECU relearns the end-stop positions. Calibration isn't optional, it's part of the repair. Skip it, and you'll be back here with a repeat code. Every diagnosis starts the same way. Read all stored codes, pending and history, not just the current one. Save the freeze frame data, RPM, load, speed, and temperature at the moment it's set. Note any related faults, since sensor or actuator codes sharing the system change your whole approach. And don't diagnose in isolation, context from other codes changes the path you take. This is the core diagnostic move. Pull up VCDS or an equivalent live data logger. Log the specified, or requested, boost, that's the target the ECU is aiming for. Log actual boost from the map or charge air pressure sensor. Then look for divergence, when and under what conditions the two separate. Graphing both channels side by side is the single best way to see the story unfold. With the data in hand, move to the physical checks. Test wastegate movement through its full range, free of binding. Excessive free play means wear. Inspect the flapper and linkage for damage or carbon. Check connectors and wiring for chafing or corrosion. Look at boost plumbing, since leaks can confuse your diagnosis. And don't rule out exhaust restrictions if other symptoms point that direction. Let's map symptoms to fixes. A sticking wastegate means a mechanical repair. A failed actuator means replace, then calibrate and adapt. An incorrect adjustment means correct it, then adapt. A bad map signal means repair the wiring or sensor. And a software or tune issue means verify calibration. 5 different root causes, 5 different fixes, and only one of them involves hardware failure inside the turbo itself. For mistakes I see constantly. Don't replace the turbo immediately, prove it's the root cause first. Don't ignore live data, graph requested versus actual before you decide anything. Don't skip adaptation after actuator work, always perform basic settings. And don't replace sensors without testing, verify with known good data first. Skip these steps and you're just guessing with expensive parts. Short answer, don't treat it casually. Avoid normal driving with an active overboost fault. Repeated overboost events increase component stress over time. A short diagnostic drive may be fine when it's safe to do so, but the priority is fixing the underlying problem promptly. Treat an active overboost code seriously, it's not something to put off. Here's the whole process laid out as one path. P0234 confirmed. Check other codes and freeze frame. Compare requested versus actual boost. Verify map and sensor data. Test the wastegate and actuator. Check calibration and adaptation. Inspect the turbo mechanically, and only at the very end, repair the root cause. Notice where inspect the turbo sits, second to last, not first. If you take one thing from this video, take this: P0234 tells you what happened, excessive boost. Diagnosis is what tells you why it happened. The turbo is only one part of a system that includes the ECU, the actuator, the wastegate, and sensor feedback all working together. Treat it as a system problem, not a parts problem. To wrap up, understand the control system, use live data, verify actuator operation, check sensor accuracy, adapt after any actuator work, and prove the turbo is actually faulty before you replace it. Diagnose first. Replace part second. That's P0234 broken down from both sides. Part 1 covered understanding the system, Part 2 covered the diagnostic and repair process. If you want the full written breakdown, head to acotex.com. And if you're chasing the opposite problem, check out the P0299 under Boost Guide and our EA888 sensor guides while you're there. Thanks for watching, see you in the next one.